Today's lesson is the third lesson in Nomenclature for Grade 10 Science in Ontario, SNC2D. And today we're talking about covalent molecular compounds. And the reminder is that when we're talking about covalent molecules, or compounds, we are talking about non-metal, okay? So these are compounds where you have two nonmetals bonded together to form the compound. Okay, so they're nonmetals, and their electrons are shared. Okay, whereas before when we talked about ionic compounds, those electrons were either donated or received. So remember, ionic compounds donate and receive electrons. Okay, so again, these are just the sharing of electrons. When we start looking at the rules for naming or writing the compounds, okay? So if you're writing the chemical formulas, okay, here are a few of the rules. Number one, the first rule is don't follow ionic rules. Okay, which means, if you looked at my previous lessons, in the ionic, the pluses had to equal the minuses. Don't follow this. It won't work when you do covalent compounds, okay? The second rule is the name tells you the name tells you the formula. And consequently, and in addition, the formula gives you the name. Okay, so if you can follow the rules for naming and things, you can't go wrong with that, okay? With covalent compounds, so C, prefixes are used. In the names. And these are numerical prefixes in the words. And those prefixes that you want to remember: mono, di, tri, tetra, penta, and then we'll go to hexa, hepta, octa, and really these ones you will never really encounter them, but they're ways to remember, okay? So mono is 1, di is 2, tri is 3, tetra 4, penta is in like pentagon is 5, hexagons have 6 sides, heptagons have 7, octagons have 8, nona is 9, and deca is 10. So those are your prefixes that you should be familiar with when we're dealing with the naming of covalent compounds. Again, remember, this is covalent compounds we're dealing with. And so here we go with the D. Here are the big rules. The first element, okay, the first element name. So if you're looking at the names, use the element name. Okay, so example, if it was C, the element name is carbon. Okay, not carbide, carbon. If the molecule or the compound has one atom in the compound, then the name stays as is. Okay? If there's more than one atom of the first one, you need to use numerical prefix. We'll do a few examples in a minute, so this should make sense. And then your second element, when you're looking at the name of it, on the second element, use the ionic name, okay, which basically means it ends in "ide." So if it was O, then it is oxide. And the second rule here is always include the numerical prefix. Okay, so if you look at this, you can always remember looking at the name, how to write it, and if you saw the chemical formula, you should be able to deduce what you're looking at. Okay, so again, the first element, use its element name. If there's more than one of them, then you use the numerical prefix. The second element in the compound, you use the sort of ionic name that ends in "ide," and then you always include a numerical prefix for the second one. Okay, so here's some examples. In the second one, it's the "ide," oxide, but you always use a numerical prefix. Some common ones you might have already heard of. If you saw CO versus CO2. Okay, so let's look at the first one. So it's C, so that's carbon. Okay, and then the O is the oxide. But the rules state if you, so there's one of them, so that's carbon monoxide. Okay, use the prefix, use the "ide," and since there's only one here, it's the name. The second one is the same, so it's carbon. You have one. But notice here there are two of those, and it's an oxide, so it is carbon dioxide, because prefix means before the word, so we're using the dioxide. If I looked at N2O4, when I see N2O4, well, the first one, the word is nitrogen, okay? But notice there's the two there, so I can't just put nitrogen because there's more than one, so I have to call it dinitrogen. And then this one is oxide. But notice, again, there's four of them, so it's tetroxide. Okay, so N2O4 would be dinitrogen tetroxide. CO2, because there's one, is carbon. There's two oxides, so it's carbon dioxide. CO is carbon monoxide. And if you look at it from the other view where you write the question down, or the name down, so if I did carbon tetrachloride, well, if I look at the name, it's only once, so that would be a carbon. Chloride, I know that's Cl, But there's the tetra, so there has to be 4 of them. So it's CCl4. And that's basically how you do covalent or molecular compounds. There's no needing to find out which is the ion charge and trying to balance it. You're looking at the name, and then you're coming up with the formula from the name, or you look at the formula, and it tells you the name based upon how many of each of the atoms. So hopefully that makes sense and is not too challenging for you to figure out. Again, anytime you have questions, you can always email me and ask the question.